Okay, let's get started. So make sure to register to vote and vote and vote for the person that you or people that you support the most. So I have your tests up here. They were in alphabetical order. They might still be. If you haven't picked it up, please pick them up. They're extremely a fire hazard at my house. Fire marshal came by and was not happy I had these, so please pick them up. I wasn't kidding about that. So any questions about the test before I go into like regrades and whatnot? Yeah.
Can you go over question number 2?
Of the test, you mean? Yeah. Okay. So question 2. I went over these in class before, but is there any specific function?
Yeah. The function where it asks show
Prime prime. Mm-hmm.
Okay. Just take a single parameter x and determine if x equals pq. Pq,
Or both primes. Mm-hmm.
So you scroll to the answer.
Yeah, I'm here.
So what I'm looking right now is basically a bool statement for plot prime. That's your identity, and then your integer is x. And you said that integer. What's the second line for?
So I'm just testing over all possible valid choices that P could be. So P has to be a prime, so I started at 2. There's no reason to start at 1. And it doesn't need to be larger than x, because if larger than x, it can't possibly be of the form P times Q. So I loop over all possible values of P, all possible values of Q, and then I just test if P is prime and Q is prime, and they multiply together to get x, return true. And then if at the very end I try every single possibility and none of them work, I return false. And then the basic part of it is, well, how does is prime implemented? Is up here. You just loop over all possible divisors, and then if any of them divide cleanly, then I return false. And then if I tried every possible divisor and none of them divide it, it must be prime. So I return true. Any other questions about the test itself? Okay, so for regrades, if I just added up the points wrong on the test, which I definitely could have, or I put the grade wrong on Blackboard, just bring that to me. That's absolutely no issue. If you think that I should have gotten more points than I actually did on this question, then as for test 1, write a list of reasons why I should regrade this question, give it to me, and then I'm going to regrade the entire test from top to bottom. And whatever grade results as of that, that is a final thing, and it cannot be negotiated after that. And I'll accept regrades through Friday's class. So anytime between now and Friday, write up your list of reasons and then give it to me. It'll be regraded. Any questions about the test or regrades or distribution or whatnot? Yeah, go ahead.
What can we say? Can you give us an example of a reason?
A reason for?
Reason for regrading our papers?
Well, obviously, if I added up the points wrong, that's obviously a reason to regrade, to re-add the points. But if you feel like I've missed something, like your answer really was right and I just didn't happen to see it clearly enough, then that's definitely a reason you should regrade. If you've looked at the solutions and you think, yeah, my solution is different, but it does the same thing anyway, and I marked it as wrong, then yeah, that's a reason for regrade. But if you think, well, you gave me 3 out of 6 for this, but I really should have gotten 4 out of 6, that's probably not a reason for regrade. Because it's like you're negotiating for 1 point for something that doesn't have a valid reason behind it. If you think, well, this is really correct because of this reason, then that's a definite reason to regrade. But any other questions about anything? So I put the statistics for midterm 1 versus midterm 2. So midterm 1's on the horizontal axis, midterm 2's on the vertical axis, just to see the distribution of where everyone is. But any other questions about the test? And I put the what I think is a reasonable set of letter grades to expect at the end of the semester right here. But any questions about this? Was there? I mean, it's on the announcements page. Okay, so I posted assignment 6 early because 1, it's a really fun assignment, and 2, it's a really hard assignment. So I think that this is the hardest assignment of the entire class, but it should be fun and interesting. So this is an assignment that I've wanted to assign for a long time, and now I finally have a chance to do so. So basically, how many of you have played a game called Alpha Bear? So download it. It's super cute and it's super fun. So I'm not kidding. It really looks like this figure. So the idea here is that you have a timer with a bunch of letters on this board. And what you want to do is you're going to form words of the English language using those letters. But if you leave a letter out and its timer goes to 0, then you don't get as big a bonus at the end. And you want to get as much points at the end as possible. So what we're basically doing here is the user's going to input the letters and their corresponding timers on the board, and then you'll come back and say, here's the best words that you should pick for the next choice. So I think this would be really, really cool, and it'll get you thinking about using arrays and everything to actually solve an interesting and fun problem here. So please get started on this because it's not trivial of an assignment. Yeah. I'm not sure if it breaks the terms of service because it's our own independent creation. And we're not hooking into the game, so there's no issue here. Any other questions about this assignment? Any questions about assignment 5? When's it due? Friday. So any questions about 5?
Yeah, is assignment 5 going to be basically like how we had to create a header file and a...
Yeah. Yeah, so you make a header and CPP file and then put the class definition with the prototypes of the functions there, not the implementation, and the CPP file is going to have the implementation, the out-of-line declaration. So you put the implementations in the CPP, and the header file just has the class definition there.
So the way to analyze it really is your header file, like your neural network, and then the CPP is just like the body, and then the actual main file is like the actions it does.
Well, it's using an instance of this. So it's like if you create a new neural network, but it has the same characteristics, let's say, as the actual neural network, but you don't look at the implementation of it. So it's like you feed in an input and it gives you an output, for instance. That's a way to think about it. Or a black box. That's another way you can think of it. Other questions about 5 or 6 or what's the weather like or how are you doing, Ryan? Or I'm doing great. But any other questions before we get back into material stuff? Yeah.
So if you have a function on an header file in public, what exactly can a user do to it? Like how would you differentiate what you do?
So this is just the art side of programming. So you can put any function private, any function public. There's no restriction there. It's just what do you think would be reasonable for a user to actually use of your class. So there may be some functions that are useful for making the class easier, but you don't need the user to see. And so those would be private. But if you have a function that says log into this website, yeah, you want the user to see that. But for things like calculating some stuff on the server backend, that's probably something that's that's a private function related, not a public function. But of course, some functions, it could be either one depending on which use case. So it really depends on the situation. But any function could be either, yeah. Right, yeah. So public means user can see it, private means they can't see it. There's a third one which we haven't seen, but it's kind of in the middle, but the ones we've seen are public and private. Other questions, yeah. The user's not inputting a word, they're inputting each letter individually with its corresponding timer, and then you come back and say, here's a word. And then what is a valid word is the ones in this words file. So you'll be reading from a file as well in this assignment. So, and you can see there are a lot of words here. So I have a thing in the assignment which gives you some steps in being able to read from a file as well. We haven't covered reading a file, but this will get you started on it. So there's some, it's really non-trivial, I promise you. So get started early, ask questions early. I'm, of course, always happy to help. Any other questions? Okay, so let's get back into material. So, of course, we've been talking about these things called arrays, which allow us to have a lot of data in one structure, and then we can access individual elements of this array using the square operator as always. So we could find things like the largest element of an array, but of course we saw that there's a much better way to do that, something called max element, or if we want to find the sum, there's a better way which is called accumulate. But of course you don't have to use those functions in order to solve these problems. You can use a array like this and then use a for loop to just loop over the array and then find the maximum value. So of course it really depends on which algorithm is good for which purpose. Okay, so this is where we ended last time. And so we were talking about these things called parallel arrays, which is not any different than a normal array. It's just we have multiple arrays that we think are in parallel. So I have, let's say, 5 is I size. So here I have 5 names, 5 averages, and 5 grades. So if I want to access the first student's data, I just access the 0th index of all 3 arrays. So name of 0 would be the name of the first student, average of 0 will be the average of that first student, and grade of 0 will be the grade of that student. So of course, if I wanted to print out the data of the user, what I would do, actually of each student, what I would do is I would loop over all possible indices from 0 to I size, and I print student with the corresponding student name, average with the corresponding average, grade with the corresponding grade, and new line. So I asked a question last time for you to think about. Is there a better way to do this? Well, what if I instead made a student class, and what I do instead of having these 3 arrays right here is I have an array of students instead. And then in this for loop, I just say, I look up the ith student now, and then I call maybe get name or something. Some function to get the name of that student. And then I have dot get average, dot get grade. So is there an advantage of making a class for this instead of doing it this way for parallel arrays? What's the issue of doing this? Well, here's one thing. What if we haven't talked about sorting it, but let's just say I was able to sort the name array. How do I sort the average array correspondingly? It seems difficult, right? Because if I sort the name array, that will mess up the names of the array in some order, but it won't change the average array or the grade array correspondingly. Whereas if I package all the data inside of a student object together, then if I sort this student array instead, then all of the data is transferred together. So the average of one student, if it moves from this place to this place in the array, the average will transfer as well. Whereas if I did it here, it wouldn't work. But what's another reason why this is a bad idea? What if I wanted to update the name of some student to be a different student? So like maybe a foreign exchange student comes in, and then now I gotta change one of the name averages and grades. Well, now I have to change a place in the name array and the average array and the grade array all at once. So I have to do 3 different statements. But what if I add another array right here? Like ID, for instance. Then I have to add another statement later that I will update that array as well. So this becomes a maintainability nightmare. Whereas if I just have a student array, then all I need to do is just update the internal representation of the student object, just one place, instead of having a new array and a new statement somewhere else. So it's, in some respects, having a student array instead of these parallel arrays is better. Why might having parallel arrays be better? So this one's a little tricky to think, but why would I want parallel arrays instead of? Yeah. Yeah, that's true, but how is an array laid out in memory? Right, yeah, so they are linearly ordered, okay? So they are adjacent places in memory. Whereas if I made a student object, or in fact a string will do the same thing. If I have a student object, then they're not initialized right there in the array. They're initialized in a place called the heap, which we haven't talked about, but they're not adjacent places in memory. And what happens is, the compiler, when it sees that you're traversing an array and you're not going out to some other place, but you're accessing adjacent places in memory, it actually can optimize that a lot faster. So having parallel arrays is almost always a good idea for optimization purposes, because then I can traverse the arrays much faster that way, versus having to go out to some random place in memory, which the compiler can't reason about as easily. So there are advantages and disadvantages is the upshot of parallel arrays. Sometimes they're good, sometimes they are not. But any questions on parallel arrays? You got a question? Yeah. The what? Yeah, we're going to get to vector. Yeah, so that has an internal normal array as inside of it, but it's not like going to random places or whatever. But we'll definitely get to that. So I'm not sure why this is here, but something that usually comes up with this type of thing is something called typedef. So this isn't anything really special related to arrays. This is just another C++ concept that they just shoved into this particular part. I don't know why. But the reason for doing this is if I want to avoid writing a type over and over, I can alias it. So I can alias unsigned int to be this capital U int thing. And so then I can use a uint instead of having to retype unsigned int. There's a better way though. And you've actually been using it this entire class. So what we can do instead is say using uint equals, I sure hope this works, unsigned int. Yeah, so this is actually the modern way of doing typedef. So how many of you remember the CPPCon conference that I made an announcement about? One of the recent talks actually said to never use typedef because that's the old C an old C++ way of programming. Using instead is much better because you get all of the benefits of typedef and additional ones. So you've been using it this way. What do you think this does, the using namespace std? What does that actually do? This is actually an empty assignment. So here, we could have said, well, we could rename std using an alias in a different way. But there's no assignment taking place here. So in fact, what I'm doing is I'm replacing std : with nothing. So that's why we've been able to do, instead of standard cout like this with std : we can remove it like this. Yeah.
So if you, that would be a global variable, right?
It doesn't have to be global, but it's just an alias. It's not a variable or anything. It's just aliasing for something else. No. So the question is, does it actually decrease runtime if I just put std : and got rid of this statement up here? And the answer is no, because the compiler, it may increase compile time by a tiny amount because it now has to look up in the namespace what function you actually mean. Whereas here, it actually, by doing this, you are definitely referring to cout in the std namespace, but it doesn't affect runtime at all because it's still addressing the same function. It doesn't actually make a difference there. Other questions, though? Yeah.
So I remember you saying that using namespace standard is like a core programming.
Yes.
Is using UN equals unsigned I feel like that.
That's the thing. There's a very good reason why this is a bad thing and why this is a good thing. The reason is here, so I can go into the reason for this. So it's actually pretty interesting. So we haven't talked about inheritance yet, but the idea here is we want to reuse code across other code. So if I make for example, a vehicle class, and then I make a car class, all of the attributes of a vehicle I should be able to use in the car class as well. The idea here is, well, the std namespace has this function, let's say cout, but could another namespace, an entirely different namespace, also have a function called cout? Or do I have to have exactly one cout function? I could have a different function in this other namespace. So what if let's just say we have that scenario, and I'm using both namespaces. So let's just say it's called other. It'll give me an error because it doesn't know what that is, but let's just say I'm using that. And then I come down here, which cout function am I calling? The one in the standard namespace or in the other namespace? So that's why it's a bad issue. But if I instead say, well, I'm going to use the one in standard only and not the other one, then the way to do that is this. Oops, like this. So this does exactly the same thing as you've seen, but now you're definitely saying I'm using the cout one. And then if I try to use the other namespace's cout, I have to do other : cout. So that avoids the ambiguity now. And then now we get all the benefits as before. So using namespace std is a bad thing to do in general. It's okay for this class, but when you go out and do this for your jobs, please don't do that. Other questions? Yeah. So the purpose of, great question. So the purpose of namespace is to, if you have a lot of code and some functions inevitably are the same name as other functions in your same library, then you have to separate them somehow. And the way to do that is with namespaces. So it's the space for names of functions that belong to a specific thing. So cout belongs to the std namespace. There are other namespaces depending on which libraries that you use. But the purpose is to separate a lot of code that happens to have the same name. That's the whole purpose of them. Other questions? Okay, so let's get back to typedef. So don't use typedef, but typedef is something that people use, and you'll come across it. So please take a be able to understand that it's there. So, but you can alias an array as well. So I can typedef a year array to be an integer array instead of just aliasing a type. So here, if I want an integer array of months, I can just call it year array, and I don't have to put the square brackets there. It's not anything really useful here. So, but of course, if I want to pass in arrays, either the individual elements or the entire array, I can just pass the array of some index, and then that'll pass, in this case, an integer, and then that'll work exactly as you might expect. There's nothing special there. But I could pass an entire array if I wanted to. So maybe I have this function which just prints the scores in this array, or something depending on the size, and then I can just pass in the entire array if I want to. So then it'll take the array, move it over to this function, and then we can do whatever we want inside the function with it. So you can pass entire arrays or just individual elements, as the case may be. Yeah, so if you pass in an entire array, they are in fact reference variables. So you don't have to put the ampersand on the argument to the function to say that it's reference. Integer arrays are by definition reference variables. So if you make a change to the array in the function, it's not a separate copy anymore because it's always a reference variable. So if you want to make sure you don't make any changes, put const as usual. Yeah, you must be careful that the array is not inadvertently changed. Yeah, of course. And then const ensures that you don't change, otherwise you'll get a compile error. But of course, we can have arrays of arrays. And then we'll extend that even more. So I'm not sure why this example is here, but the only thing that I can think of why it's here is maybe we have 12 students in this class in 3 columns of students and 4 rows, for example. And then maybe this student is at row 0. So row is the first index right here, and column is the second index. So if I want to go to the next column, I change not the first index, but the second index to be 1 and then 2. And then if I want to go to a different row, I change the first index and not the second one. Okay? So you can think of this like a spreadsheet. But what do you think the computer actually sees in memory? Does it see a 2D entire array, or what does it see instead? So what it actually sees is one giant array. So it doesn't see this 2D array thing. That's just for our benefit. So let's just say that I wanted to look up exams 1 of 1, for example, the second column, second row. How does the computer figure out where that element is? So it works exactly the same way as for normal arrays, but now it has to do a little bit more work. It figures out, okay, well, your first index is 1. That means I got to skip over all of the elements with first index 0. And then now your second element is 1. Your second index is 1. So once I skipped over the first index 0 people, now I got to look up in this sub part of it right here where the second index 1 actually is. So you can think of this as you're treating the outer thing as one array, and then you're skipping to a subarray. Then you're treating that as an array, skip to a subarray, until you finally find the element. So here, index 1, skip over all of the indices of 0, and then here, skip all the second indices of 0, which there's only 1 of them. And so therefore, we can look up exams 1 of 1 here. So it works exactly the same as before, but now it has to do a little bit more work. Assigning to elements works exactly the same way as for normal arrays. So if I wanted to look up the third row and the second column, so index 2, index 1, and assign it that way, then I can assign 86. There's no difference here. And then we talked about initialization lists before. So I can initialize a 2x2 array by putting an extra set of curly brackets on the outside. And then the first row is right here, followed by a comma. Then the second row is right here. So it's like I'm putting inner initialization lists inside. So it works exactly the same way as well. And it says you can omit the inner curly brackets, but it's harder to reason about if you have a lot of data right here. Okay. And then if you want to traverse over this thing, then I think we have a, nope, we don't. So what we do here, instead of just going from 0 to the length of the array minus 1, what we do is we go from the row number starting at 0 through the row number minus 1, and then an inner for loop inside, which has the column start at 0 and go through the column number minus 1 instead. And then inside there, we look up the row number and the column number. So all it is really is just the same thing we did before, but with an extra loop to handle the columns of the array. So rows on the outer loop, and then columns on the inner loop. And we can actually see this in action. So we can take this example. Let's get rid of some of this stuff. And then let's put this initialization in here. So the number of rows in, let's change it a little bit. So here we are going to do maybe another set of items like this. So how many rows are in this 2D array? 3. Does it actually matter if the 2 is the rows or the 3 is the rows? No, because I can just view the array sideways if I want to. It doesn't actually matter, but it may depend on what order I want to traverse these. But maybe I want to traverse it row order instead of column order. So here I'm going to go row starting at 0, and then row less than what number? 4, 2, 3. Why 3? What is the highest row index? 2, because it starts at 0. So I got to go through 2. I could equally well say less than or equal to 2. It works exactly the same way. Then add 1 to the row every time. Then I'm going to make a copy of this, instead of row again, I'm going to put column. But should I put col less than or equal to 2? What should I change that to? 1. Because there's only 2 columns. So maybe then I want to see out, exams of row, then of column. And then maybe with a space in between. And then maybe to make everything nice, I'm going to put a new line after I've processed one entire row, which is right here. So then if I run this, we should get a nice representation of our table. Any questions on how we were able to traverse over this 2D array, though? We just make a for loop or whatever for the rows, and then one inner one for the columns. Any questions on that? Okay, so we know how to do that. But of course, we could change this to n-dimensional arrays. One time I actually had to deal with a 6-dimensional array before. So you can actually make these go very, very, very deep if you actually want to. But it really depends on the use case for it. Usually you don't go more than 3, but it really depends on the use case, as I've said. But of course you can have arrays of objects. There's nothing special about, you must have an int or a double or float or whatever. For the type in an array, you can have your own user-defined types as well. So I can have 10 squares in an array. So nothing special there. Okay, but any questions on arrays before we get to my favorite part of the entire class? Well, second favorite, I guess. Okay, so The problem, so what are some problems with arrays? Just native arrays as they are. Yeah. Right. So if I have an array, I can't, there's no functionality for me to add more to an array because it may be possible that the array is right here and then the next element right after the end is something for some other process in the system and you can't allocate memory right there. So that's an issue. So what's another issue? There's no attributes for arrays. So what if you wanted to look up the size of an array? Well, what if we declared a constant up top? Then I know the size of the array, but what if we didn't? What if I just said int array square brackets 5 and I put a 5 in there? Is there a way for me to look up later the actual size of the array? There actually is, but in general, this won't actually work. So what the standard library has is something called vector, and it's a godsend among the entire library. My favorite class in the entire standard library. So what's a vector? So it's a class wrapper around an array. Okay? So you can look at a vector and it works exactly the same thing as an array to you, but it has much more functionality and it's far, far, far better to use than an array. So it's a one-dimensional array by default. It has a flexible number of elements. But here's the thing. On the back end of a vector, it has a normal array on the back end. So is this claim wrong? Because we just said arrays can't grow, but it just says right here, we have a flexible number of elements. So what do you think it does instead? Exactly. So here's what happens. Suppose our array is full of elements. I can't put anything else into this array. And now I say, yeah, I want to add one more thing to this vector. Well, it can't add anything else because the array is full. So what does it do? It makes a new array of larger size, let's say twice as large, and then moves all of the elements of the original array over. It copies them down, and then now I have space to put the new element. Okay? But if there is space that I haven't used in this vector yet, it just puts it in. So it's flexible in the sense that we don't have to handle making the array larger. We just forward the work off to vector. Isn't object-oriented programming nice? I don't have to think about it anymore. We can just forward it off to vector, and the array grows and shrinks, and we don't actually care what actually happens. So, but we do need to include a header for it. So there is in its own header called vector. Okay, so the great thing about vector is something called a templatized class. And we'll get to templates in a few weeks. But what you need to do is, right after the word vector, you have to put angle brackets and some type inside. And what that indicates is the scores vector here has ints in it. Okay, so it's just like making an int array, but here I'm saying the vector contains ints. This volumes vector has doubles in it. And then we could, for example, set an initial size. So we really can do exactly the same work as we did with original arrays, but now we can grow and shrink, and we'll see how to do that. So we can use the square bracket operator just like arrays to access elements in the vector. So it really works exactly the same way as arrays did. Okay, so if we want to initialize something, remember that weird example where I made an int array and then like one of the elements was not set to 0, it was some weird number? You can actually, in the initial statement for vector, say, yeah, I'm going to have 20 things in here, and all of them are initialized to 0. You can set an initial value if you want to. But you can also copy from another vector. So we saw a problem was being able to copy from one array to another. and maybe the sizes of the arrays are not the same, that could be an issue. So again, vector handles all the work for you. You don't have to think about it. Here's an interesting, if we go back here. So this is a class. This is a custom class where we have square bracket operators. There's no native way in classes to redefine the square bracket operator to actually access something in a vector in your class, for example. So does anyone know how they actually pulled this off? So one of the awesome things about C++ is that we can redefine operators when we use a class. So for example, if we make a player object in a game, for example, and then maybe we want to move this player from here over to here, what we can do is we can overload the plus operator to say, yeah, this player, wherever it is, I'm going to add 5 to his position, so it moves over here. So we don't have to make some method to say, oh, dot set location, whatever the location was before, plus 5. We can redefine operators to do exactly what we want. So what they've done is they've redefined the square brackets to say, yeah, the usual behavior of accessing elements in an array is with the square brackets. Let's redefine it for here. So we're not going to redefine operators probably until the end of the semester, but it's actually pretty cool. So if I do this, if I instead make a vector, so of course I have to include a vector. So if I make a vector, actually let's change this back to what you're used to. So let's make a vector of int scores, and let's say that there are 20 of them initialized to 0. And then I could see out, for example, scores of 10. So that'll access index 10 in the vector, exactly the same way as arrays do. So there's no difference here. And of course, we can expect it to be 0 because this constructor of vector says, oh, there are 20 elements in there, and they're all initialized to 0. So we get exactly the same behavior as you might expect. But we can make a vector bigger. So for instance, this member function called pushback says, oh, at the very end of the array, I want to put the value 75 in the very last place is a new member in this vector. So just to show you that it actually works, let's do scores.pushback 75. And then we can access the size member function, which will print the length of the array, of the vector. So what should we expect to be printed here? 21. Because there were 20 things before, we added 1, we have 21 now. Let's see. So what else could we do? What was one of the issues if I wanted to look at the very last element of an array? So if there are n elements in an array, what is the last index? N minus 1. How do I determine n again, the size of the array? It was difficult, right? What if I wanted to do this? So there's a function called back, which will print the last element in the vector. Isn't vector amazing? I swear, it saves my life many times. So 75 is the last element in the vector because we just pushed in the back of the vector. What if we wanted to put it on the front? What do you think the function's called? Push front. I thought there was a push front. Vector push front. Okay, so you have to use insert here. So unfortunately, there's no push front. There should be. But there's an insert function which will insert the element that you want to push in at that exact point But what happens to all of the elements that were there and anything to the right? What do you think happens? They're all shifted one element to the right. So if I wanted to insert 75 at index 10, for example, I would say at index 10, put 75. Iterator position. Oh, okay. I know what's wrong with that. So this is a little weird thing, but you have to do this. So scores dot something called begin plus 10, but there's a reason for that. But if you do this, then 75 will be inserted at index 10, as we should expect. So I guess there's some work to do on the part of compiler writers, yeah.
What exactly does dot back do again?
So dot back is technically a reference to the last element in the internal array. Yeah, so that's the one that you really should care about is scores.back. So that'll give you a reference to the back element. If you wanted the first element, you can say dot front instead. Or index 0 or index size -1, either way will work. Yeah. Mm-hmm. Yeah, technically it's the address. Yeah, but we haven't done pointer arithmetic yet, so I don't expect you to know.
You said they were redefining the square factor operator, so does that mess up if you were to use a normal array if you include factor?
No. So an array is built into the C++ language. Vector is a custom class that's built, so there's no interference there. I should mention, though, that there is, in recent versions of C++, an array class. So not a built-in array, an actual array class, which is far better than making an array by itself. So what I recommend to people is never use raw arrays unless you absolutely need it. Use vector if you need things to grow and shrink. Otherwise, use the array class built into the language. So for that, what you would do is you would include array. So then I could, instead of doing vector here, I could say array of int. But here I have to specify the size because the array class is constant size. So here I'll set to be 20 of scores. And then this will do hopefully exactly what we want, which is what we want. Any questions before we break? Yeah. I think you can only do one at a time. There may be a way to push back a whole vector at once, but I'll have to look. There's almost zero overhead of using vector, comparatively, yeah. I'll see you on Wednesday.